Today's lesson I'll be talking about perfect competition, can be found in chapter 13. And this is the beginning of the market structure unit. We'll look at perfect competition, monopoly, oligopolies, and monopolistic competition. And each of you will have a presentation to do in class, of course, on these market structures as well. So let's look at the learning targets then for today. How a price-taking firm determines its profit-maximizing quantity of output, which we'll see is where marginal revenue equals marginal cost. How to assess whether or not a competitive firm is profitable or if they're making losses. How to evaluate a perfectly competitive firm's situation using a graph. How to determine a perfect competitor's profit or loss. How a firm decides whether to produce or shut down in the short run. Why industry behavior differs between the short run and the long run, and what determines the industry supply curve in both the short run and the long run. So you can see it's quite a bit of information, but a lot of it's going to have to do with graphing. There'll be the presentation of the market structure in class, which will get a lot of the characteristics of perfect competition, and then this will help with the graphing part of it. And just note that this does take some time and some practice, and you'll get better at it after doing it for a while. But the first couple of graphs, you might wonder what the heck's going on. But just stick with it, and you can always pause and rewind whenever you need to. In the last chapter, just a reminder that the marginal cost curve eventually increases. It kind of looks like a check mark, if you remember that. The average cost curve is U-shaped, and the marginal cost curve is always going to cross the average total cost curve at the minimum point. So here's a graph then of that. You can see this here. So again, the marginal cost curve is the check mark. The average cost curve is downward sloping, and then it hits the marginal cost curve and then goes back up. So that's important to note. I'll be harping on that a lot. But the average cost curve is downward until it hits the marginal cost curve and then goes back up. So it has to do that. And the average variable cost curve lies below the average cost curve because the average cost curve is both the average fixed and the average variable cost curve. So both of those put together is the average total cost. And so the average variable cost curve will always lie below the average cost curve because it's just the average variable. It's not the average variable plus the average fixed. So one of the learning targets was how to determine where quantity is at, and that's going to be where MR equals MC. And maybe I could even made that even bigger. That's just a really important concept here. So marginal revenue, when marginal revenue equals marginal cost, that's when profits are going to be maximized. And that is called the price-taking firm's optimal output rule. And so that's where they're always going to be looking at to produce. Let's see, we're going to look at a scenario here with Jennifer and Jason's farm. So this is a graph, and I will try to kind of walk you through this graph. This is Jennifer and Jason's tomato farm, and they'll maximize its profits by producing bushels of tomatoes up to a point at which marginal revenue equals marginal cost, just like we said in the last slide. And that's the optimal output rule. So the profit is maximized by producing the quantity at which the marginal revenue of the last unit produced is equal to the marginal cost. Always remember, MR equals MC at the optimal quantity of output. This will be true for any profit maximizing firm in any market structure, not just perfect competition. So let's look at Jennifer and Jason. We can review how to apply the optimal output rule here in this table. And the second column contains the farmer's variable costs, as you can see. And the third column shows its total cost of output based on the assumption that the farm incurs a fixed cost of $14. So if it's a fixed cost, notice that 0 bushels, then it's still going to be $14 because that's fixed. Whether I make 0 or 7, that fixed cost remains the same at 14. And the fourth column shows their marginal cost. And so note that in this example, the marginal cost initially falls as output rises, but then begins to increase, so that the marginal cost curve has that familiar check mark to it. The fifth column contains the farm's marginal revenue, which has an important feature. It says that Jennifer and Jason's marginal revenue is constant at $18 for every output level. The sixth and final column shows the calculation of the net gain per bushel of tomatoes, which is equal to marginal revenue minus marginal cost, or equivalently in this case, market price minus marginal cost. As you can see, it is positive for the first through fifth bushels. Each of these bushels raises Jennifer and Jason's profits. For the sixth bushel, however, you can note that it's -2. It's a net gain is negative. Producing it would decrease, not increase profit. So 5 bushels are Jennifer and Jason's profit maximizing output. It is the level of output at which marginal cost rises from a level below market price to a level above market price, passing through the market price of $18 along the way. So that is a pretty long explanation, and you certainly can rewind that and listen to that again. It is very important to understand marginal revenue, marginal cost, and understanding that that's where it's going to be most optimal for any market structure or business, that's where they would want to produce. If you produce any more than that, it's going to be negative, and if you didn't produce at that point, well, you could have still gained some more money. So you want to produce where that is 0. And here's a graph of that, so you can see their check mark for the marginal cost curve, and you can see the numbers used for the average cost curve. And the marginal revenue curve is perfectly elastic because they are price takers. They got to take whatever price is given to them. So that demand curve, that marginal revenue curve, is a straight horizontal line there. And again, that's perfectly elastic because of all the close substitutes. They are homogeneous products. Those are using real data, real numbers, and that example is actually in your textbook too that you can look at. From now on, though, when I use graphs, I won't be throwing in the numbers. I just want to show you the last 2 slides, primarily for you math people out there who are wondering why the heck the curves look the way they do. And so that's for you guys. For those that don't care, then that's fine too, because it probably doesn't matter a whole lot, just kind of the reason why they look the way they do. And it's going to be more important of being able to draw the representation of what they mean rather than the actual numerical data at this point. You can see at point C there, it just says it's MR equals MC, and that would be where they would want to produce. A teacher, a workshop that I went to in Iowa, actually, she gave me this idea here, so I can't claim it as my own, but she used the acronym Mr. DARP. And so what we're going to find out is that marginal revenue curve that we just saw in that last slide, that actually is a demand curve, the average revenue, and the price of the product. The most important part is that it's the demand curve and the price of the product. So you keep that in mind when we talked about marginal revenue and we draw that in, that you remember that that's the demand curve for the product and the price of the product. So let's look at firms in the short run for perfect competition. In perfect competition in the short run, they could make a profit. And so if they were to make a profit, that means the price would have to be above the average cost curve, which makes sense. I'm getting money that's above the cost that it takes to make it. So the price has to be above the average cost curve. And of course, you're going to produce where MR equals MC, like we mentioned a couple of slides back. So get ready to graph a little bit. Again, I know it might be a little hard at first, but it will get easier. Perfect competition in the short run with the possibility of earning a profit. And so we will need side-by-side graphs. And this is going to require quite a bit of curves, but this will get easier over time. So this is our first shot at it, and we'll do it a few times in this lecture, and it will get easier, I promise. So the side-by-side graph, you have your vertical axis where you have price, And your horizontal axis we have the quantity. And then that first graph is the industry. And so we can label that industry, and that would be in the millions. That's everybody producing this good. And then you can draw your supply curve and your demand curve. So that's pretty simple. And then you're going to do a side-by-side graph, like I said. So you're going to draw your price and quantity next to it. And then this will be for the firm. And since it's a firm, it's just in the thousands. This is just the single business that you might own. So you take where supply and demand are equal right here, and you are going to draw that line straight over, and that is your marginal revenue curve, or Mr. DARP, which stands for marginal revenue, demand, average revenue, and price. So that's the price of my product, and it's the demand curve for my product. So that's marginal revenue. Then you're going to draw your marginal cost curve. It's just a check mark. And this is kind of how we start out every graph for perfect competition. This is pretty simple. We start there, and then we start adding some more stuff. So this is looking at a profit. And so that's what we're going to draw next. So if you're making a profit, you need to put in your average cost curve, and if the marginal revenue is the price of the product, then your average cost curve would have to be below that price to show that you have a profit. So the average cost curve is U-shaped, as we've seen before, and it's going to hit the marginal cost curve at the minimum point and then go right back up. And that's your average cost curve. And then we want to identify where the output is. So we want to find the rule for output is MR equals MC. So I find that point. I draw that straight down. And that's going to be the quantity for my firm. And then I can also look to find my profit. And that's where MR equals MC down to the average cost curve and straight over. And then that would actually be my firm's profit here. And there's your first graph for perfect competition. And this is just a nicer looking graph probably than my scribble marks, but I thought it might be helpful for me to do it too. But again, you have supply, demand, you find the equilibrium, you draw that price straight over, and then that's your Mr. DARP. You draw on your average cost curve, you draw on your marginal cost curve with your check mark. You find where MR equals MC, draw that output down, and then you can also locate your profit there with that lovely rectangle. And so again, that's just a short run equilibrium for profit for perfect competition. So whether you like my graph or the computerized graph, whichever one helps you out the best, that would be just fine to use. A second one thing that might happen in the short run is that they could be incurring a loss. So if they're incurring a loss, then that must mean that the average cost is higher than the price that I'm getting for my product. And so the average cost curve has to be above the price. Now back in the second or third slide, we talked about average variable costs too. Well, if you're incurring a loss or you're not shutting down, then that means that the price must be between the average cost curve and the average variable cost curve. And so while we would be losing money, they'd be minimized because I could still pay for the average variable cost. So let's see what that would look like. All right, we're going to draw perfect competition with a short run loss. So again, they're going to be side-by-side graphs. I draw my price, I draw my quantity. And again, this is the industry, and that's in terms of millions. And then I can draw my supply curve and my demand curve. Then I draw my graph next to it. And I have price, and I have quantity. And then again, this is the firm, and so that would be in thousands. So again, I look at where supply and demand are equal here, and I draw that point straight over. That is my marginal revenue curve. And I also need to add my marginal cost curve. And again, this is kind of the bare bones here. This is what it looks like before I start looking at if I have a profit or a loss. So if you can start to kind of memorize this part, it'll just make it that much easier. And so I can add in my average cost curve. Now this time, the price must be below the average cost curve because I'm not making very much money. I'm losing money. So the average cost curve has to be above the marginal revenue curve. So I draw my average cost curve, hit the minimum of the marginal cost curve, and go up. And that's the average cost curve. And now I actually need one more curve because it says I'm at a loss. I'm not shutting down, so I'm able to pay for some things. And so what I can pay for are my average variable costs. So I need to draw in that curve. So again, it's U-shaped as well, and it's going to be below the marginal revenue curve because it's my average variable cost, and I can pay for that. So I am operating, but I'm operating at a loss. If I shut down completely, I'd actually lose a lot more money. This is minimizing my losses in the short run. So I can identify the area of where quantity would be. So that would be where MR equals MC. So I find that point there, draw a line down. There's my quantity for the firm. And then I can find the loss. So I would draw a line straight up to the average cost curve and over, shade in that lovely rectangle, and that would be the loss for this firm. Again, this is just a short run loss for perfect competition.